Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. This is Mr. Simon, and we are here to change our world with chemistry. So today we are still talking about polymerization, and we are basically going to talk about plastics and fibers today. So we talked about the different types of polymers, and we tried to talk about the different classification of polymers, and we observed that these polymers can be classified in different ways. So today we are going to classify our polymers in terms of plastics or fibers. But before we continue, let's try to look at what we looked at last time on our slides, because our time was little and we didn't cover all of them. So, but I had left you with some work last time. I told you to draw the polymer or illustrate the polymer of polylactic acids. So this is our polymer. This is our polymer. So as we said last time, is this polylactic acid has a monomer called lactic acid. So this is a polymer which is composed of two monomers or two repeated units of lactic acid. So let's try to illustrate it here on our blackboard. On our blackboard, we have lactic acid, which is this one. Lactic acid. This is our lactic acid. Lactic acid is a good polymer. Good. So when you are representing our polymer, we try to show. We can try to represent it in form of. Okay, our amino acids like this, but it's not an amino acid, but we represent the functional groups which are going to take place in formation of our polymer. So I'm going to use two repeated units here. Then I do like this, and here we are going to remove H. You can remove H, or we can remove OH. Then here we remove OH. Then we remove H here, remove also OH. So our polymer will be like this. So we have O, oxygen, so CH, then CH3. So we have our functional group, this one combining two oxygen to form our ester. So as we've seen, our polylactic acid is a what? Is a polyester. So water is formed, then we say plus what? Water. So there are two, we can say 2N what? Water. So this is our polylactic what? Acid. So as you see on our blackboard, it's similar to the one we have here on our slides. So let's continue. So we are going to pass through, we are going to give also the uses of polylactic acid as an ester or as a polyester. So polylactic acid can be used. The good thing about polylactic acid is biodegradable. So it can be used in the making of some of these things here, cups, disposable cups, which are biodegradable. These cups, these packaging materials, which are used to pack apples. You can even see in our pictures here, to pack different fruits. You see these different cups where we put our juices. These are all disposable plastics. And the beauty about it is that they are biodegradable. So they can be used to make containers for food service applications like we see here in our pictures. They can be used to make bottles like you see here. Then tableware like you see here, which is disposable. Then outdoor applications, then biomedical applications, very many applications of polylactic acid. The beauty about polylactic acid, as we have said, it is biodegradable. So let's continue also, and we pass through our condensation polymers. Last time we looked at them on the blackboard, but we can pass through them here on our slides because we can look at some of our uses. As we said last time, these polymers come from the monomers like this is coming from a diamine, and this one comes from, and also a dioic what? Acid to get nylon 6,6. So today we just want to talk about the uses. So of nylon 6,6 and nylon 6,10 and maybe nylon 6. So it can be used to make bearings, gears, fishing lines, nets, tires, bottles, ropes, clothes. Yeah. As we said last time, the uses of nylon 6,6 are similar to the ones of nylon 6,10. So we can look at some of the illustrations here. So we have the footwears, which can be made out of nylon 6,6, nets, which are actually fishing, like for example, this fishing line, we can have the fishing nets. They can be used to make tents, making of threads, these threads turn into, can be turned into clothes. Then it can be used in making of nuts and bolts, clips, then the gears, the ones you can see here, the bearings, which you find in our engines, can be used in making of clips, making of bags, making of waterproof clothes. So nylon is very, very important, as you've seen. Then again, let's continue, and we talk about Kevlar. We talked about Kevlar last time, and we said Kevlar is a polyamide, or we can call it a condensation polymer, which comes from benzene 1,4-diamine and benzene 1,4-dioic acid, which are actually illustrated here on our slides. So we have a polymer, and this polymer, we call it what? Kevlar. So Kevlar, properties of Kevlar, we said is known for its fire resistance and higher strength, meaning it has a higher strength than steel. Like last time I told you that it is 5 times stronger than what? Steel. So it is used in making of firefighting equipment, making of blade proofs, making of bulletproof vests, making of crash elements, sports equipment, tires, and ropes, as we are going to see. Nomex also is somehow similar to Kevlar, but for it, the difference between Nomex and Kevlar, this one is 1,3-diamine, and the other one is 1,4-diamine. But they are all obtained from a diamine and the diol, or we can call it a dioic acid. So this time we are using a diol, but it can also be a dioic what? Acid. And you see even here in our illustration is that our product is actually HCl, and here it is what? Water. So this is Nomex, our polymer. Also it's known for its heat and fire what? Resistance. So it is used in making of fire-resistant gloves, jackets, military equipment, garments worn by firefighters, and racing what? Drivers. Because when drivers are racing, sometimes they have a risk of having, for example, fires. So they are also good to it's also good to have these jackets and dresses. So let's look at some of the pictures. Here we have, this is a bulletproof vest, normally worn by the police. This is we can call them the diving gloves, very, very resistant to fire and also heat. This we have the walking boots, normally put on by people who work in industries where there is high heat or high temperatures. Then military helmets, which normally protect the military people from, they are normally bulletproofs. So they can protect the military people or the policemen or the soldiers, especially from for example, gunshots. So we have these cut-resistant gloves. You try to cut. Here they are trying to show you that you try to cut with a knife, but it cannot be cut through. Even the heat, it cannot easily go through. It cannot be easily burnt by fire. So especially they are made out of Kevlar. So if we can also have bicycle tires, especially the bicycles used in racing. Normally, the tires are made out of Kevlar, very strong, even car tires. So some of the car tires can be made out of Kevlar, very strong. We also have here the fireproof clothing, which are normally put on by those firefighters when they go in to do their job. So in addition to that, we have more pictures here, which are military applications. Application in military, as you see, this is our head mask. This is an application of people who are firefighters, which is normally part of the police department. And here we also have another application of Nomex. Here they say Nomex 3 is used in airline seat covers, which is composite of 95% Nomex and 5% what? Kevlar. So you observe here, when they are making, for example, the airlines, or we can say the aeroplanes or the helicopters, their seats can be covered with or made out of Nomex. Why? Because Nomex, we have seen, is fire resistant. In case of fire, it can be able to withstand the very high temperatures. Then even Kevlar. So Nomex is also used as electrical insulation because of its what? Strength. So as we've seen, Nomex and Kevlar, they find very many what? Applications. So this time we have shown them in form of what? Pictures. In form of pictures. Then we have also polyester. Last time we were trying to talk about polyester. This polyester actually, and the one we have talked about today, which is actually polylactic what? Acid. This polyester is thiolene, and thiolene is formed from benzene 1,4-dioic acid, or we call it terephthalic acid. Then also another one is ethylene glycerol, which is ethane 1,4-diol. So they lose, this one loses H and this one uses OH, and they form a polymer we call thiolene. So properties of thiolene, they are not as strong as the ones of Kevlar and Nomex. But thiolene is also finds a special application in the making of clothes, in vehicle repair, making of boats, aircrafts, and making of what? Bottles. So it has a nickname called the PET, P-E-T. So the bottles which are made out of thiolene are normally written as PET or PTE, which comes from this word polyethylene terephthalic phthalate, which is an ester. And we call it Dacron in USA. So we can see here, we have another example of formation of our thiolene. Thiolene can also be formed from this monomer here, where we have an ester. So you observe that this time we are going to lose this we can call them methoxide ion. It is lost, and then it combines with H to form what? Methanol. Like we go back to our definition of condensation polymers, which says that condensation polymers are polymers formed from monomers having different functional groups, followed by elimination of small molecules like water, like HCl, and now we have what? Ethanol. So let's look at the uses of our thiolene in picture form. Thiolene is the highest percentage of thiolene, made around 70%, is used in making of clothes. This is sometimes when you check on some of your clothes, you'll find they have written on polyester. Polyester, this time, that polyester, it means thiolene. Sometimes they write 87% polyester. It means it is coming from this monomer, this polymer. And also thiolene is also basically known in the making of bottles. Such bottles are very good because they are biodegradable. As we saw when you are talking about biodegradable and the non-biodegradable polymers. So those polymers which are condensation polymers, they can easily be eaten by bacteria, and they can be decomposed. So they are good. We can say they are better plastics, or we can say they are better what? Polymers. So let's go to today's topic, or today's lesson. Today's lesson, we are basically talking about plastics. You know, sometimes when we are talking about polymers, we use them interchangeably. We talk about polymers, and sometimes we call them plastics. So we are going to describe our polymers in form of plastics. When someone talks of a plastic in chemistry, we say a plastic is a polymerized organic substance. So it means from that note, we recognize that every plastic should be a what? A polymer, but not every polymer should be a what? A plastic. So a solid of high molecular mass, which at some time of its manufacture is shaped by flow. Yeah, so normally when they are making plastics, at a given time of the manufacture of these plastics, we carry out heating. We carry out what? Heating, or we can say melting. So we cannot shape these plastics to different shapes except when we heat. So when we heat, they melt, and then we put a shape of a container. And as we put the shape of the container, this plastic will take the shape of our container. So this is why we have these plastics in different what? Shapes, as you've seen them. So then again, when you talk about their types, we again look at the thermal properties. This is why when you are talking about some properties of polymers, we included this, or classification of polymers, thermo-softening plastics, and we try to go on the other side of plastics, because basically when you are trying to include these heat properties, we are trying to talk about plastics. So thermo-softening plastics and thermosetting what? Plastics. Another name for thermosetting plastics is thermohardening what? Plastic. So let's briefly remind ourselves about this. We said thermosoftening plastic, the thermoplasts are those ones which soften on heating and can be remolded, meaning they can be remolded, or we can say they can be recycled. So most of our plastics are thermo-softening plastic, the one we have talked about. Then we can also revise again about thermosetting plastics, which we call the thermosets. These are plastics that once molded cannot soften. Or we can simply say, as I said last time, these are plastics which do not soften on what? Heating, to create a clear difference between thermosets and thermosofts. So examples of some of these polymers, we have melamine. Which is used to make plates, cups. Like for example, here in our illustration, we have an example of melamine. So this, as I told you last time, melamine has an intermediate property. When you fill the plate, or when you fill the cup made out of melamine, or made out of a thermosetting plastic, it is in between the properties of a clay cup and a plastic what? Cup. So these are some of the examples, and I believe most of you have some of these things at home because they normally have a nice appearance. They are not as expensive as clay plates or clay cups, and they are not as cheap as the real plastics, or we can say these plastics which are thermosoftening what? Plastics. And actually they are not as dangerous as thermosoftening plastics. That is in terms of our health. So then let's continue. We have polyester resin. We are not going to talk about it. We have phenolic resins, e.g. bakelite, which is an electrical insulator. So bakelite has many applications, as we are going to see, very many applications. And we are going to try to look at the structure of bakelite. So these are some of the uses of bakelite. You see, it is used to make these necklaces, the making of toys, making of watches. But normally, if you look at them, they are normally, these plastics were normally for old times. So making of these, the ones they put on the hands, making of radios, making of people who enjoy chess, making of those chess. If you enjoy the game of chess, you can see this is a castle, this is a king. This is a king, this is a castle, this is a pawn, this is let's leave this one. So then we have those people who enjoy, we can call it Ludo. We have this, which is also a thermosetting plastic made out of bakelite. So bakelite can also be used especially in high application, making of arc switches, making of these things. You know, these things are long time. These were used a long time ago. Making of buttons. This is a cookware, but the plastic part of it is made out of bakelite. These things here are the necklaces, and also making of pool balls. So this is the application of our bakelite. So we have more examples of thermosetting plastics, uranium methanol, vulcanized what? Rubber. So the think we talked about the difference between a thermoset and a thermosoft. The thermosoftening plastic, when you heat it, you can easily change shape and you form another, or we can say you can be recycled. But a thermoset, as if you try to do that, it will change to powder, especially in presence of what? Heat. So you'll observe that the softening plastics may be better because they can be recycled. So let's continue, and we talk about our formation of bakelite. Hope you are seeing this very well. So we have phenol here. Phenol is bakelite is a mixture of phenol and methanol. So phenol and methanol, they react together as you see in our equation. So because phenol, if you remember when you are talking about chemical reactions of benzene and its derivatives, phenol has the OH group and it's an electron donating group. So it forces ortho and para position. So here we have the ortho what? Position, the ortho position. So this ortho position can react with another phenol to form our polymer. This is just trying to show how the polymer. So this is like a two-step process, but you recognize that, like for example, in our next illustration, you observe that this formaldehyde and phenol combine together, so you can form in the ortho and para position, meaning we can also have here ortho, both the ortho position and both the para position. So you recognize what we have here. Then in the presence of, when you are carrying out polymerization, you recognize that they can combine it together to form a long chain. So we can combine with the phenol as we've put here, or we can combine with another which is as it is itself. So you form a long chain of which is a polymer. So the monomer is this one. Our alcohol, a mixture of alcohol, which is hydroxymethyl phenol. So they undergo polymerization to form our polymer, which is bakelite. Which is what? Bakelite. But this bakelite can also undergo cross-linking. The reason it undergoes the different cross-linkings is because of its ability to form ortho and para what? Positions. So this is an example of bakelite. Actually, we can do this experiment in the lab, and we see how we get our bakelite. So let's continue. So we are going to talk about the limitation of plastics. Limitation of plastics. Many plastics like polyalkenes are non-biodegradable. So we are talking about the dangers of plastics. So they are non-biodegradable and they cause land pollution, water pollution, and plastics also cause air pollution when burnt. So who can give us another danger of plastics? There's one we have talked about today as we are discussing. We say that actually plastics can also cause cancer. That's why it is good not to use plastic cups while taking tea or hot things. So it can cause cancer to our bodies, which is very dangerous. So if you have any way to avoid using plastics when you are taking tea or when you are taking porridge or when you are taking anything hot, you can avoid it. So here are some of the illustrations of our plastics dangers. You see, when you burn them, they cause environmental pollution, which can lead to, can call it global warming because of release of carbon dioxide. You see here, when they find their way in the soil, they will reduce the penetration of water in the soil. When they find their way into the water bodies, they can cause death of our water animals. You see even here an example of a bird which tried to eat plastics and it ended up dying. So after some time, they found out in its stomach that it had what? Plastics. So plastics are very dangerous. As we've seen, they are very important. It is hard for us to survive today without plastics. Anything you touch, even the clothes you are putting on, some of them follow under what? Plastics. But we can try to reduce the effect of what? Plastics, or we try to stop the effect of plastic. Like for example here, we have methods we use, like for example, recycling. That means taking back to the plastic to the industry. You can reuse your plastic. For example, if you finished using it if you bought a plastic or a jerrycan of cooking oil, you can wash it and use it for fetching water, or for example, you can use it for example, buying milk, or we can also renew plastic. Renewing plastics means here we can talk about a simple way of, for example, you've bought a jerrycan of shampoo and you finish using your shampoo and the jerrycan is still not very old, and then you can also, it is a similar way of reuse. You can wash it very well and then you reuse it. Then proper disposal of plastics, make sure you dispose our plastics very well. After using your plastics, we thank God for the government which helps us in this situation. Make sure to make sure that people properly dispose their plastics. Then we also encourage the use of biodegradable plastics, like what the government is trying to do. It's trying to encourage the use of biodegradable plastics, meaning those plastics which are not easily decomposed by bacteria are stopped from their use. So you can give me more ways we can reduce the effect of what? Plastics to the environment. So let's talk about fibers. Fibers, when someone talks about a fiber, it means anything which can be made in the form of threads. Examples of fibers, we have natural fibers, cotton, wool, silk, and threads. So here are examples. Wool comes from animals, silk comes from caterpillar. Then you also have synthetic fibers which are artificially made. When we are talking about fibers, when we are talking about the polyalkenes, we talked about, for example, of polypropylene, which is oron. We also talked about an example of condensation polymers like polyamides, which is nylon. We also gave an example of polyester. Polyester, which is styrene. Anything which can form clothes normally is a what? A fiber. Is a what? A fiber. So hope you followed and you enjoyed our lesson today. So today, in this lesson, we have tried to describe our plastics in terms of we have tried to describe our polymers in terms of plastics and in terms of what? Fibers. So I'm going to leave you with some work to do. So here is some exercise. Make sure you try out this exercise. Like the first question is telling you to describe or to state the meaning of thermosoftening what? Plastics. So you try out this work, give an example and explain the synthetic thermosetting what? Plastics. Write an equation for the formation of nylon 6,6. State the type of polymerization involved. We have talked about this. Then name two types of polymerization. That is question number 2. State the structure requirement for formation of the polymer above. So you try to give the structure requirement. Write the names and the structure formula of two naturally occurring what? Polymers. We also gave examples of natural polymers. So you make sure you try out this work. Thank you very much once again for following me. Thank you for tuning in. Thank you for enjoying this lesson. God bless you very much. See you next time.